Welcome to Unacademy, the largest online e-learning platform. Welcome to Unacademy semester exams. Course that we are dealing is network analysis and transmission lines crash course, and the topic is port networks. And topic for today is image and iterative impedance. Image and iterative impedance. For that, let me tell you about myself. I am Vai Shravan Kumar, having 7+ years of teaching experience and mentored more than 5K students for GATE and engineering services, and also cracked GATE. And let me also explain you about the Unacademy Learning app installation procedure. Type Unacademy Learning app in Google Play Store. You'll get this step 2 install. Click on install and check this GATE and ESC and click on this plus. You'll get this get subscription. Click on it. Have two types of subscriptions. One is plus, other one is iconic. You'll get a dedicated mentor for your preparation in iconic subscription. You can use my code YSK10 to get the maximum discount and click on this proceed to pay. And once you click on proceed to pay, you have many platforms for the payment like debit card, credit cards, EMI, UPI, wallets, and net banking. Using any of these payment options, you can get subscription to the Unacademy, the largest online e-learning platform. Varnasri, good evening. No, good evening. Soumya, good evening. Welcome. Let me tell you about this Evolve for Gate 2022 and Send for Gate 2023. So I'll give you an idea about it. Evolve for Gate 2022 and Ascend for Gate 2023. And the batches has already started. You can get subscription. You have top educators. So hurry up and get subscription to Unacademy to achieve your goals. So that was about Evolve for Gate 2022 and Ascend for Gate 2023. Top educators of Unacademy will be dealing your subjects. Do subscribe to Unacademy and pay for your exams. The topic for today is image and iterative impedance. Image impedance and iterative impedance. See one by one what are these. So first let me tell you about image impedance. What is image impedance is, let me explain you with some diagram, then we will define it. Let's say you have an asymmetrical two-port network like this. This is an asymmetrical two-port network. It has port network, as I told you, it will have two pair of terminals, one at the input, other one is the output put as well as the output. This if you observe, let me give V1 and I1 here, and this is I2 and V2. Similarly, you have I1 and V1 and I2 and V2. What is image impedance is, if this asymmetrical two-port network, asymmetrical port network, this is again an asymmetrical two-port network. If an asymmetrical two-port network is terminated by an impedance, say in the case 1, I'm considering this as case 1 and this as case 2. If this is terminated by an impedance of, let us say Zi2, this is impedance, I'll call this is impedance as Zi2. And if you are looking through this input terminals, the impedance is Zi1. And if you terminate the first port with an impedance of Zi1, impedance measured here will be Zi2. So this is the meaning of image impedance. If an asymmetrical two-port network is, let me write it, if an asymmetrical two-port network is terminated with an impedance of Zi2 at port 2, and if and the impedance measured at port 1 Zi1. Similarly, if port 1 is terminated by an impedance Zi1 and impedance measured at port 2 is Zi2, then call this Zi1 and Zi2 as image impedance. This is called as an image. Yeah, good evening. So this is about image impedance. Now let us see is iterative impedance. Iterative. After this, we will derive some expressions for them. Now let us say in the same fashion you have an asymmetrical network, input terminals as well as the output terminals. What is this is iterative impedance is, let us also write these values first, that would be easy. This is I1 and you have V1 across these terminals. This is I2, say this is V2 across these terminals. Clearly this is I1 and V1 applied across these terminals. This is I2 and V2 applied across this. So this is an symmetrical port network. And this is also an symmetrical. What is iterative impedance is, if you terminate the second port, let's say with an impedance of Zt, and if you measure the impedance at this point, it is Zt. Similarly, if you terminate the first port with an impedance Zt and measured impedance at second port is Zt, such an impedance, such a network, such an impedance is said to be iterative impedance. And you can define this if a port of two-port network is terminated by an impedance of Zt and impedance measured at other port is also Zt, then Zt is called iterative impedance. What is this? Is an iterative impedance. So this is iterative impedance. So I hope you have got the difference between image impedance and iterative impedance. Right? So image impedance is if a asymmetrical two-port network is terminated with an impedance of Zi2 at port 2 and impedance measured at port 1 is Zi1, and if port 1 is terminated with an impedance of Zi1 and impedance measured at port 2 is Zi2, we can say Zi1 and Zi2 are the image impedances. So This is image impedance if port 1 is terminated with an impedance of Zi1, and if you measure the impedance at second port, it is Zi2. And if the impedance measured at port 1 is Zi1 and port 2 is terminated with an impedance of Zi2, then we can say that Zi1 and Zi2 are called as image impedances. And what is iterative impedance? If you terminate a port with some impedance Zt and impedance that is measured at the input port is also Zt, and if you terminate the first port with an impedance of Zt and measured impedance is also Zt, such an impedance is called as iterative impedance. Such an impedance is called as iterative impedance. Right? These are iterative and image impedance. Now let's see how iterative impedance is expressed in ABCD parameters. That is, or image impedance first. Image impedance or image parameters. Image parameters in terms of ABCD parameters. Image parameters in terms of ABCD parameters. Let's see how do you do this. I'll just first draw the block diagrams. That will be easy for you. You just draw the block diagrams. Let me draw a let me draw a circuit like this. So this is the network. This is the symmetrical two-port network. So I want to represent the pair of terminals at the input as well as at the output. And this is at the input and at the output network. It's not a block, it's in terms of a blocks I'm representing. So this is an asymmetrical two-port network. Symmetrical two-port network. Similarly, this is again an asymmetrical two-port network. If you measure, let's say this is I1 and here the voltage is V1. So if you measure here, this is Zi1. If you terminate this with an impedance of Zi2, you'll get this Zi1. Similarly, if you, this is I2 actually, right? So if you just terminate this with Zi1 and this is I1 and the measured impedance here is Zi2, voltage here is V2, this is I2. So here if you observe, this is I2 current. You can also take one more current I2 is minus I2 here, and this current is minus I1 which is towards this Zi1. So I can write things here. One is, what is Zi1? Zi1 is the impedance measured across this first port, that is V1 by I1. Similarly, what is Zi2? Zi2 is equal to V2 by I2. This clear? Is voltage across this Zi2. The voltage across this V2. V2 is equal to minus I2 into Zi2 minus I2 into Zi2. What is V1 in this case? If you see, this is the voltage V1 here. What is that voltage? It is Zi1 into minus I1. So minus I1 into Zi1. Now you need to substitute these conditions, substitute these two conditions in. Srinivas Nayak, good evening. Welcome Srinivas Nayak. Welcome to Unacademy. So you need to substitute this in ABCD parameters because we are writing in terms of ABCD parameters. Let's try to write this in ABCD parameters. Let us consider ABCD parametric equations. V1 is equal to AV2 minus BI2. I1 is equal to CV2 minus DI2. I've considered these two, V1 and I1, and V1 I1, V2 I2. Just replace this first case, case 1. Let's consider first case. What is case 1? That is V2 is equal to minus I2 ZI2. And you need to find ZI1, which is V1 by I1. Substitute these conditions here. So you'll get V1 is equal to A into what is V2? Minus I2 ZI2 minus B I2. Similarly, what is I1 is equal to C into minus I2 ZI2 minus BI2. You want the ratio of V1 by I1, so divide these two equations. So V1 by I1 will be equal to, just take common minus I2. Take common minus I2, will get A ZI2 plus B by, if you take minus I2 in this also common, is C ZI2 plus D. You can cancel this, and therefore what is V1 by I1? It is ZI1. ZI1 is equal to V1 by I1 is equal to A ZI2 plus B by C ZI2 plus D. This is ZI1. Shivkumar, good evening. Chandrakiran, good evening. Come to Unacademy. Similarly, this is case 1. You also need to find case 2. So let us take case 2. What is case 2? What is the case 2? This is case 1. This is first case. This is second case. This is second case. What is that? V1 is equal to minus I1 ZI1 and ZI2 is equal to V2 by I2. Now let's consider the equations. Now let us try to consider, we need to substitute this V1 and find V2 by I2, right? So because you are interested in finding V1, V2, I2, I'll try to write these equations as V1 is equal to AV2 minus BI2, I1 is equal to CV2 minus DI2. So I can write V2 and I2 also. Just take the inverse of this. You'll get D by AD minus BC into V1 minus D by AD minus BC into I1. Similarly, C by AD minus BC into V1 minus A by AD minus BC into I1. So you'll get these equations. Just take the inverse of this matrix. You can write this in terms of matrix and take the inverse. You'll get E2 is equal to E by AD minus BC into V1 minus B by AD minus BC into I1. Similarly, I2 is equal to C by AD minus BC into V1 minus A by AD minus BC into I1. So in this, try to substitute this condition. So you can write V2 is equal to E by AD minus BC into V1. What is V1? Minus I1 ZI1 minus E by AD minus BC into I1. You have I1 common, so you can minus I1 common and write the rest of the things. That is DZI1 is B by AD minus BC. This is what you'll get it. Similarly, if you take I2 is equal to you can write C by AD minus BC into V1 minus I1 ZI1 minus A by AD minus BC into I1. Even here you can take minus I1 common and write CZI1 plus D, CZI1 plus A, okay, AD minus BC. Now when you make V1 is equal to this value, you need to find impedance at the second port. What is the impedance at the second port? It is ZI2 is equal to E2 by I2 is equal to, you divide these two values, this value by this value, minus I1 will get cancelled. You get EZI1 plus B by C Zi1 plus A. Even the denominators will also get cancelled if you divide these two values. So what is Zi1 is equal to A Zi2 plus B by C Zi2 plus D. So let's write these two values. So Zi1 is equal to A Zi2 plus B by C Zi2 plus D. C Zi2 plus D. Similarly, Zi2 is equal to Krishnachari, good evening. Zi2 is equal to C Zi1 plus B by C Zi1 plus A. So you have these two values. Try to substitute Zi2 in this. So you can write Zi1 is equal to A into C Zi1 plus B by C Zi1 plus A plus B by C into C Zi1 plus B by C Zi1 plus A plus. Now just try to take LCM. A into C Zi1 plus B into C Zi1 plus A. Okay. The denominator will get cancelled. C into C Zi1 plus B plus C into C Zi1 plus A. Just try to cross multiply them. So Zi1, first just try to simplify. AD Zi1 plus AB plus EC Zi1 plus AB by CD Zi1 plus BC plus DC Zi1 plus AD. So this is what you'll get it from this. You're just substituting Zi2 value in this Zi1. And when you try to cross multiply this, I'll just try to cross multiply this. If there is any mistake, just please let me know. So CD Zi1 square plus BC Zi1 plus BC Zi1 square plus AC Zi1 AD Zi1 is equal to AD Zi1 RHS side, this value, plus AB plus BC Zi1 plus AB plus AB plus AB plus 2AB. You can cancel these terms. See, AD Zi1, AD Zi1, BC Zi1, BC Zi1. So what can you write this? You can write this as, if you take Zi1 square common, that is CD Zi1 square, CD Zi1 square. What you will get that? You can directly write it as, so this is 2CD Zi1 square is equal to 2AB. You have 1AB plus 1AB, 2AB. To cancel this, it is Zi1 square is equal to AB by CD. So Zi1 is equal to root AB by CD. This is the image parameter corresponding to image parameters in terms of ABCD corresponding to the first port. Similarly, you can substitute Zi1 in Zi2. Similarly, substitute Zi1 in Zi2. Let's do that. Let's try to substitute Zi1 in Zi2. So what is this value you get? So it is, have Zi2 is equal to Zi1 plus B by Zi1 plus A, and Zi1 is equal to, just try to substitute this, D into Zi1. Zi1 is A Zi2 plus B by C Zi2 plus D, and you have a plus here. So let's try to write this. Yes, you already have a B here, B by C into Zi1. A Zi2 plus B by C Zi2 plus D plus A. Just try to simplify this. Take the LCM and multiply. Is dA Zi2 plus BD plus BCZI2 plus BD. Okay, you can cancel the denominator directly and write ACZI2 plus BC plus ACZI2 plus AD. Right? You can cross multiply them. So it is ACZI2 square plus BCZI2 plus ACZI2 square plus ADZI2 is equal to ADZI2, this part, is BC plus BCZI2 plus BD. Sorry, this is BD and BCZI2 plus BD. Now here if you observe, we can cancel these terms. BCZI2, BCZI2, ADZI2, ADZI2. What is that you got? 2ACZI2 square is equal to 2BD. You can cancel this 2. So ZI2 square. ZI2 square is equal to BD by AC. So ZI2 is equal to under root of BD by AC. So this is the value you got for ZI2. We have also got ZI1 is, we have also got ZI1 here. So ZI1 is equal to root AB by CD. ZI2 is equal to root BD by AC. So just write down them. ZI1 is equal to root AB by CD. Is it right? Yes, it is right. Next ZI2 is equal to root BD by AC. So these are the two image parameters in terms of ABCD parameters. Now let us take one question and try to solve. How do we do that? Let's see. Find the image parameters of the network shown. Find image parameters of network shown. And the given network is something like this. Just take random values of. So this is that given 3 ohm, 2 ohm, 4 ohm. This is what generally I take. This is given as I1, V1, I2 and V2. Alright. So now if you observe this, what is the image parameters that you know? You can directly use formula. What is image parameters? Write the image parameters. The image parameters we have ZI1 is equal to root AB by CD. ZI2 is equal to root BD by AC. Means if you can find the values of A, B, C and D for the given network, you can just substitute these values here. You can substitute these values here and find ZI1, ZI2 image parameters directly. Let's try to take this and try to find ABCD parameters for the given network so that you will be able to find image parameters. So let there be, you have to take this circuit. So क्या करना अभी? You need to find these 3 ohms and 4 ohms. V1, I1, I2 and V2. So just write the ABCD. We want to find the values of A, B, C and D. So let's try to write first the value expressions. V1 is equal to parametric equations. AV2 minus BI2. I1 is equal to CV2 minus DI2. We already know how to determine ABCD values. So let's try to do that. How do we determine ABCD? First, we'll try to make I2 is equal to 0 case 1. When I2 is equal to 0, what is I2 is equal to 0? It is just open circuit port 2. So let's try to open circuit this and assume some voltage of V1 here, and there is some current. Because this is open, you already know that what is the expression for V1. V1 is equal to 3 into I1 plus 4 into I1, because current will go to this point and it will not go to this because it is an open circuit now, right? Okay, because I2 is equal to 0. When I2 is equal to 0, it is an open circuit. So when it's an open circuit, it's an open circuit, you get I2 value 0, so the total current will flow like this. So this is 1. And what is V2 is equal to? V2 is the voltage actually across, it is a drop across 2 ohm and 4 ohm, but the current in 2 ohm is 0. Therefore, the voltage across 2 ohm is also 0. So V2 is the voltage across 4 ohm directly. So it is 4 into what is the current? I1. So when you make I2 is equal to 0, what is the value that you get? A. What is V1 by V2? So we'll write V1 is equal to 7I1. From this expression, if you see, if I2 is 0 in this, A is equal to, what is A is equal to? A is equal to V1 by V2. What is V1? 7I1. V2, 4I1. It is 7 by 4 units because voltage by voltage. Similarly, if you make in this equation, if you make I2 is equal to 0, what is C? C is equal to I1 by V2. From this expression, you can directly get what is I1 by V2. It is 1 by 4 units. Current by voltage, it is no. So you have this as the A value and this as the C value. What is A value? A is equal to 7 by 4. C is equal to 1 by 4. So this is case 1 when you make I2 is equal to 0. Similarly, we will make E2 is equal to 0 and let's check. So let's draw the diagram once again. You need to draw this diagram. And V2 is 0. What is V2 0 indicates short circuit, right? So this is second case when V2 is equal to 0. What is V2 is equal to 0 indicates? It is short circuit port 2. This is short circuit port 2. And this is 3 ohms, 2 ohms and 4 ohms. And this will be I1. You'll assume a voltage V1. Now, if you short circuit this, V2 is 0, but still there is some current I2. So I'll take some current minus I2, which is opposite to this. And we need to derive the relation between V1, I1 and I2. You can write V1 is equal to I1 into R total. What is R total that you need to find? What is R total? When you short circuit this second port, 2 and 4 will be in parallel. So 2 into 4 by plus 4. And this combination will be in series with, so it is 8 by 6 plus 3. 3 6 is 18 plus 8, 26 by 6. So it is 1 za, 2 3 za and 2 3 za, 13 by 3. So V1 is equal to I1 into 13 by 3. This is one expression. Next you need to write the other expression. I2. Minus I2 is the current in this parallel branch. 2 and 4 are in parallel. This is 4 ohms and this is 2 ohms. This current is I2 and this current is minus I2. This is 4 ohms. This is 2 ohms. So what is the current in any parallel branch? Total current. What is the total current that is coming? I1. So total current I1 into opposite branch will be 4 by the total resistance is this. So when you make, let's see here, if you make I2, write those equations first. We'll write these equations. What is this? What are these equations? V1 is equal to AV2 minus BI2 and I1 is equal to CV2 minus DI2. When you make V2 is equal to 0, this part is made 0. So you'll get B is equal to minus V1 by I2 and D is equal to minus I1 by I2. So let's try to find that. So from this, you can directly find what is minus I1 by I2. What is minus I1 by I2? Is 6 by 4. What is minus I1 by I2 actually? What is minus I1 by I2 if you see? Is D. It is the value of So D is equal to minus 6. Sorry, minus I1 by I2 is 6 by 4. Just this to the denominator, you'll get it. What is the other ratio? V1 by I2. So divide this by this. So V1 by I2. What is this value? It is B, minus V1 by I2. So it is minus V1 by I2 is equal to 13 by 3 by 4 by 6. Right? So it is 13 by 3 into 6 by 4. So it is, you can write 2 3s are 2 2s are 3 3, 13 by 2. So value of B is 13 by 2, and ohms, this is impedance V by I, and this is, you don't have any units, so D is equal to 6 by 4. Let's write all these values at one place. So we got the value of A, value of B, as well as value of C, and the value of D is A 7 by 4, C 1 by 4. A 7 by 4, C as 1 by 4, and B as 13 by 2 and 6 by 4. 13 by 2, 6 by 4 is 3 by 2. What is ZI1? ZI1 is equal to root AB by CD. That is under root, substitute this. A 7 by 4, B 13 by 2, C 1 by 4 into 3 by 2. Cancel these two. So you can just write this value 17 into 3 by 3. Just find the value. So similarly, ZI2 is equal to root BD by AC. Is that so or not? BD by AC. You can see BD by AC. Multiply that under root of B value. What is the value of B? 13 by 2 into D is 3 by 2 by A is 7 by 4 into C 1 by 4. This is 2 2's 2 2's. Just try to simplify this to get the values of A, B, C, D. This is 13 into 3 by 7 by 4. So these are the values of ZI1 and ZI2. This is how you will determine the values of ZI1 and ZI2. Hope you are clear with this concept. So let's see what have we done. Karthik, good evening. Come to Unacademy. So let's see what have we done now. We were actually given a question like this. What was it? Find the the question was find image parameters of the given network shown. So we have written image parameters in terms of ABCD. So we know how to find ABCD parameters for this. So we have just substituted, we have just taken this network and considered the ABCD parametric equations, and one case as I2 is equal to 0, that is open circuit second port, and written the equations for V1 as well as V2. Because I2 is 0, we have V1, I1 and V2. We got the values of A and C as well here in this case, and next we have taken other case V2 is equal to 0, that is short circuit port 2. When V2 is 0, you have two values, one is V1, I1 and the other one is I2. Just try to find figure out a relation between these three, then we got the values of B as well as D. If there is any calculation mistake, just try to do that. So we have made the second condition and try to find the values of B and D. Once you get all these values of A, B, C and D, you can substitute in ZI1 and ZI2 also. So that's how you'll get the values of the image impedances. You can just write out. Okay, so Here you'll get the value, and that is in terms of ohms. To simplify, you'll get these values and you can just write it in terms of ohms. So let's also consider one more question, and I'll just give you an idea how to do that. Let's take one more question. Question is given, find the image parameters of given network. The network is given something like this. This is the given network, and the values are given as 5 ohms, this 15 ohms, this is probably 10 ohms, and 20 ohms. This is 1 dash, and this is 2 dash. So this is the given network. I want you guys to solve this problem. This is one of the important questions that was previously asked also. So just try to solve this. You can just redraw it first. So first write what are the image parameters. Zi1 is equal to under root of root AB by CD. Zi2 is equal to root BD by AC. And just try to redraw this with this idea. This will be easy for you. Let us take these two as, I'll just give you an idea how I'm drawing this. Let us consider this is 1, right? So this is 1, this is 2 dash. There is, see, let's call this as 1 and let's call this as 1 dash. Between 1 and let's say this is 2 and this is 2 dash. Between 1 and 2, what is the resistance? 5 ohms. Between 1 and 2 dash, what is the resistance? 15 ohms. Sorry. So again, between 2 dash and 1 dash, if you see between 2 dash and 1 dash, if you see there is a resistance of, between 2 dash and 1 dash, there is a resistance of 20 ohms. Similarly, between 2 and 1 dash, this is 2 and this is 1 dash, is another 15 ohm resistor. 1 and 2 dash, yeah, 1 and 2 dash, sorry, this is 10 ohms, right? So this is 10 ohms. So this is 10 ohm resistor. Just try to, you can also try to find the values of A, B, C, D, or you can also try to find the values of, so here the current directions must be taken something like this. This is I1, and from this I2 it is, so this is I2, and this voltage is V2, and the voltage across this is V1. You can find in this way. You can use concept of ABCD that we have discussed in the previous session, previous problem, and find the values of Zi1, Zi2. There is another way of finding it. You can also find Zi1 is equal to root over ZOC into ZSC1, and Zi2 is equal to root over ZOC2 into ZSC2. This is another expression that will also be useful. We'll also use this expression and try to solve this circuit in the next uh, sessions, but as of now you can try this and try to solve this network. There's one problem that is given as it has some sort of practice problem for you, right? If you still did not get it, you can just comment it. I'll just give you the solution. I'll also do that solution now. Because we are lagging in time, so I also want to discuss about the iterative impedance. I'm also trying to give you some idea on iterative impedance. So let's take that iterative impedance. As I told you, iterative impedance is the impedance. The two-port network is terminated with some impedance, and the measured impedance is also same as the terminated impedance. We call it as a iterative impedance. That means I'll just draw it very simple enough because we have already discussed this point. And I'll just consider some network so that it will be easy for you derive some expressions. Let's say there is a T network inside. I'll also draw that, don't worry. Now let's say if you are measuring impedance here, there is some impedance. If this is ZT1, then if you measure the impedance here also you'll get ZT1. Or if you terminate this with some impedance ZT2, get it as ZT2, right? So this is what is iterative impedance, that is defined as the impedance when connected across the pair of terminals which gives the same value of the impedance across the output terminals, other pair of terminals. If you are terminating this with ZT1, you will get a ZT1. If you are terminating with ZT2, in this case, you'll get a ZT2. Or if you're terminating with this one, ZT1, you'll get ZT1 here. So let's try to take some a T network, which is very useful, very easy to solve also. So let us consider this network. And let us assume that it is terminated with some impedance or the resistance of Z1, and here the measured impedance is also Z1. Let us call this as Z1, Z2, Z3. Now what can you write? Z1 is equal to, it is the series combination of these two, that is ZT1 plus Z2, and this is in parallel with Z3 and in series with Z1. You can write Z1 plus Z3 into Z2 plus ZT1 by ZT plus Z2 plus ZT1, right? So you just can cross multiply or simplify. ZT1 is equal to Z1 into, just multiply this, Z3 plus Z2 plus ZT1 plus Z3 Z2 plus ZT1 into Z3. Let's try to write this more simplified form. ZT1 is equal to, this is Z1 Z3 plus Z1 Z2 plus, I'll write this term at the end. First I'll write this Z3 Z2 plus Z1 ZT1 plus Z3 Z2. Right? So let us assume that this value is a constant, Z1 Z2 Z3 Z4, sorry, Z1 Z2 Z3, this being a constant, let us assume that it is X. Not take it as X, let us take it as some, right? Let's consider this value as A instead, that will be very much fine. So ZT1 is equal to Z1 ZT1 plus Z3 ZT1 plus some value of, right? So from this you can write this equation as, you have just multiplied this here, LCM, taken the LCM, you also need to multiply this term because you have taken this LCM and you have a denominator. So just don't forget to write that denominator here. This denominator is, this denominator value you need to write here. The denominator value is, sorry, this is the denominator. So write that denominator value, which is Z3 Z2 ZT1 Z3 plus Z2 plus ZT1. This is by Z3 Z2 ZT1. So you can just write this as ZT1 into, cross multiply, Z3 plus Z2 plus ZT1 is equal to Z1 ZT1 plus Z3 ZT1 plus K. So multiply this, ZT1 into Z3, ZT1 into Z2, ZT1 square is equal to Z1 ZT1 Z3 Z1 plus K. You can cancel this. Z1, Z3, Z1, Z3. You cannot cancel this. So you can write this as Z1 square. Yes, if I take ZT common and take this term to the left hand side, it is Z2 minus Z1 minus K is equal to 0. Now you can find the roots of this equation. This is something like ax square plus bx c, where a is equal to 1, is equal to z2 minus z1, c is equal to minus k. What are the roots of this? Minus b plus or minus under root of e square minus 4ac by 2 into a. So that is minus b minus z2 minus z1 plus or minus under root of b square is b square z2 minus z1 whole square plus 4 into a is 1, c is minus k by 2 into 1. You can write this is what? This is the value of zt1. So zt1 is equal to, get zt1 and 2 minus z2 minus z1 plus or minus under root of z2 minus z1 whole square plus, because minus into minus will be plus 4k by. So from this value of this, using this expression, you can find the value of zt1, iterative impedance, for a given problem. Similarly, if you just try to find the value of zt2 at the other port, you can also get it as minus z minus z1 minus z2 plus or minus under root of z1 minus z2 whole square is 4k by 2. This is what you'll get it. So if, let's see if there is any calculation error. So what have we done? We have just taken, let us see, we have just taken this iterative impedance. This is an asymmetrical two-port network. This is an asymmetrical two-port network. We have considered a T network. We have considered some T network. So we have considered this T network and tried to write this Z1 and Z2 are in series and Z3 is in parallel. So we tried to calculate that and try to find this ZT1. Is Z1 plus Z3 into Z2 plus ZT1 by Z3 plus Z2 plus ZT1. So we have Z1 into this denominator will come here. So you don't have it previously. So you'll have this denominator coming to this point. Z3 plus Z2 plus Z1, Z3 plus Z2 plus Z1 plus Z3 by this denominator. So it is Z1 Z3 plus Z1 Z2 plus Z1. I'm writing this term first here. So Z3 Z2 plus Z1 plus ZT1 plus Z3 into ZT1 denominator. Let's try to cross multiply this here. I've taken an assumption that Z1 Z2 plus Z2 Z3 plus Z1 Z3 is equal to Z, or you can take it as Z square, doesn't matter, it is Z, some value. So instead of Z I have taken this value as total value as K. Just take it as K. So substitute here K. It is, this value is completely K. Z1 ZT1 plus Z3 Z. Just multiply this, it is Z3 into ZT1 Z1 into Z2 ZT1 square is equal to Z1 ZT1 Z3 ZT1 plus K. So this is Z3 ZT1 plus ZT1 into Z2 plus ZT1 square is equal to Z1 ZT1 Z3 ZT1 plus K. You can cancel this. Z31 T1 Z3 ZT1. So finally you can write Z1 square plus Z into, if you just take this term this side, Z2 minus Z1 minus K is equal to 0, and you can find the roots and you'll get its value. It is minus B is minus z2 minus z1 plus or minus under root of z2 minus z1 whole square plus 4 into k. K is equal to what is k? z1 z2 plus z2 z3 plus z3 z1. So this is how you'll determine the values of z1 and zt2. Similarly, from this you can get the values of, you can, if you just take the other part of this, like if I just want you to if you want me to show, I'll just show you something like this. You can just take this as zt2 and considering this as a T network, this value is zt2 again. So let us consider this as z1, z2 and z3. So you can write zt2 is equal to again z2 plus, this is, these two will be in series. So zt2 plus z1 into z3 by z3 plus zt2 plus z1. So from this zt2 is equal to, you'll get z2 z3 plus zt1, sorry, zt2 plus z1 z2 plus zt2 plus z1 to z3 into z3. Again z3 plus zt2 plus z1. So from this you can write z2 into z3 plus z2 plus z1 is equal to z2 z3 plus z2 into, what is this value, z3 into z2 plus z2 into z2 also. We'll get z2 plus z1 z2 plus z2 z3 plus z1 z3. Now you can just multiply them and cancel out. Let's try to multiply this. You get z2 z3 zt2 square z1 zt2 is equal to z2 z3 plus zt2 z2 z1 z2 plus zt2 z3 plus z1 z3. Simply you can cancel this zt2 z3 zt2 z3. So from this you'll get it as zt2 square minus or plus into, just take zt2 common. zt2, if you take common z1 and take this term to the other side, is z1 minus z2 is equal to, write all this, z1 z2 plus z2 z3 plus z1 z3 and consider this as value k. What can I write from this? It is z2 square as z2 into z1 minus z2 minus k is equal to 0. To apply the roots, it is minus b plus or minus under root of b square minus 4ac by 2a. This is minus z1 minus z2 plus or minus under root of z1 minus z2 whole square minus 4 into 1 into, a value is 1 here, b is this value, c is minus k by 2 into 1. So this is zt2 value. So therefore zt2 is equal to minus of z1 minus z2 plus or minus under root of z1 minus z2 whole square plus 4k by 2 into 1. This is how you will determine the value of z2. It depends upon which type of T connection and where you are connecting the load and where you are measuring the iterative impedance. So this is about image and iterative impedance. So we have learned about image and iterative impedance today, right? So as I always tell you, we have India's #1 study channels. All these India's #1 study channels you have: Unacademy, Electrical Junction, Foundation, Patishala, SSC, JEE, Computer Science, GATE, and Unacademy semester exams. So once again, thank you all. Please do like this video, share this video, and use my code to get maximum discount of 10% on your next Unacademy subscription. And subscribe to Unacademy and click on this bell icon to get notification of my classes. Thank you all. Thank you once again for joining me this session on image and iterative impedance. Thank you.